Hello, welcome to Geometric Progression Sequence. In this lesson, I'll be walking you through the calculation that deals with geometric progression. So let's go into it without wasting much time. Before we dive into the calculation, we need to know some little things about geometric progression. So, what's a geometric progression? A geometric progression is simply a sequence in which two consecutive terms differ by a factor. So geometric progression is also called exponential sequence. Okay, you get that. Then I must tell you, you need to master the formula of last term for geometric progression, and that's the formula that you use to find maybe the last term or any term in a particular GP sequence. So, and the formula is given to be Tn equals AR raised to power n minus 1. Notice right here, AR, this simply means A times R. Then this R is raised to power this n minus 1. All you need to do is to commit this formula to memory, and when you do that, you're sure to calculate your geometric progression. Okay, now the Tn is the n term or the last term. You get that? So then the A is the first term and the R is the common ratio. You get that? And while the n is the number of terms. I hope you see all this. Tn is the last term or the n term, and your A is the first term, and the R is the common ratio, and the n is the number of terms. So with this formula you can calculate any geometric progression term. Okay, now so let's look at the sequence of a geometric progression. We are just using an example right here. So for instance, you're given this example 2, 4, 8, 16, then 128. What we have as the first here, which is this number 2 here, is the first term, and the one that follows it is called the second term. So after the second term, the next one that followed it is the third term. So our 16 here is the next one after the third term, and that is the fourth term. Then in this particular sequence, now you can see right here, this 128 is the last term here. So we call this last term, or you can also call it the end term. Okay, so we're getting at it. Okay, now we need to define some little things so that you can get acquainted with your geometric progression. The first one we're looking at common ratio. That's from that formula. So what do we mean by common ratio? Common ratio is the constant multiple, or we call it factor, between two consecutive numbers. And we denote this by making use of our R, letter R. Okay, now common ratio is given to be second term all over first term, or you can say third term all over second term. Okay, let's consider this example right here. We have this sequence here 2, 4, 8, 16, 32. So if we follow the common ratio, we see that this is first term, this is second term. So 2 is first term, 4 is second term, and 8 is third term. So if I need to get the constant multiple or the constant factor between two consecutive numbers that are close, that's first term and second term, all I need to do is to say 4 divided by 2. You can see it here, 4 divided by 2, and that will give 2. That means our multiple, which is the constant factor, our common ratio, will be 2. If we do the same thing to this, 8 divided by 4, that's the third term divided by second term, we'll still get the same constant multiple. If we say 16 divided by 8, that's the fourth term divided by the third term, so we still get to the order of, if we say 32 divided by 16, we're still going to get the same 2. So common ratio there, R, is 2. So we're looking at the first term right now, and the first term is the first number that starts a particular sequence, and we denote this by letter A. So it's denoted by letter A. So let's look at this example right here, 2, 4, 8, 16, 32. So the number starting here, which is this 2, that is the first term. So the first term A is 2 here. You get that? Good. So what about this sequence right here? What's the first term here? The first term here is this 1/4. You've gotten that. You're doing a great job. So let's go to the next one. So we're looking at the last term. So what do we mean by the last term? The last term is simply the last number that ends a particular sequence, and we denote that by n term, or you can write tn term. You get that? So let's look at a particular sequence. For example, this sequence, we have this sequence right here. If you look at this sequence, it has an ending, and what is ending right here is this 2, 5, 6. So the last term here is this 2, 5, 6. You get that? Example 1. Okay, we are asked to find the common ratio of this GP sequence. We are given this GP sequence 8, 24, 72, 216, and 648. So how do we find the common ratio? You remember the formula to be second term divided by first term, or we can say third term divided by second term. Either way you want to do it. Okay, so we have the number 8, 24, 72, 216, 648. So our common ratio will be second term all over first term, and so we will have 24 divided by 8. You've got that. So 8 can go in 24. 8 here, that's 1. 8 can go in 24 3 times, and so we have 3 divided by 1, and 3 divided by 1 would give us 3. So our common ratio R equals 3. Example 2. So we're given this question right here. The first term of a GP is 15, while its common ratio is 2, and we asked to determine the system of the sequence. What I need to tell you is this: as you've studied the question, write out the things you're given. That's a very important thing you need to do, and that is what will guide you to use the formula in a proper way. So let's see right now. We're given the first term of this GP to be 15, so write it down. First term A equals 15, and then we're also given the common ratio, which is R, to be 2. You've get that. And we are asked to determine the system. Since we have system right here, it means our number of term n will be 6. You've gotten that? Good. You're doing a great job. So we are asked to determine the system, which is the T6. Okay, now, so we're going to make use of the last term formula. You remember that's the geometric progression formula. So, and the formula is Tn equals AR raised to power n minus 1. Having written the formula down, next thing you need to do is to put in these values that were given into this formula of the GP. So remember, our n is 6, our r is 2, and our a is 15. So let's put that, and so we have T6 equals 15 times 2 raised to the power 6 minus 1. Don't be confused right here with these times that we have here. AR simply means A times R. You've got that. That's the reason why we have 15 times 2. I have raised to the power 6 minus 1. So what is 6 minus 1? That will give 5. And so we have 2 raised to the power 5 there. So our T6 equals 15 times 2 raised to the power 5. Okay, now, so what will be 2 raised to the power 5? Well, using your head to do that, that's very simple. So 2 times 2, that's going to give 4. 4 times 2, that's going to give 8. 8 times 2, that's going to give 16. And 16 times 2, that's going to give 32. That's 2 in 5 different places. Okay, now so our 2 raised to the power 5 is 32, and so we have T6 equals 15 times 32. Okay, now so we have 15 times 32. What does it give us? Equals to, that's 480. That means our T6 is 480. Well, let me also show you, in case maybe you're finding it difficult to work out your 2 raised to the power 5 using your head. All you need to do is to press 2 and then press this exponential sign. This one that is like V facing down. You understand? That's the exponential sign, raised to the power sign. So raised to the power, then press the 5. Press equals to. So you can see right there, 32. Okay, now so our final answer for the T6 is 480. So let's go through the next example now, so that you can have full understanding of what geometric progression is all about. Example 3. Well, we're given this GP sequence, minus 6, minus 18, minus 54. So this is an infinite sequence, and we're asked to determine the 8th term. First thing you need to do is to list out the things you're given. That's the things that are related with geometric progression formula. You know, in geometric progression formula, we have A in it, we have N in it, and we have common ratio in it. N is the number of term, and the A is the first term. Okay, so from this sequence here, we know that minus 6 is the first term. So let's write that out first. First term A equals minus 6. Okay, next thing we need to do now, you know, we're asked to find the 8th term here. It simply means our number of term here will be 8. So our number of term N equals 8. So next thing we need to determine, you know, in geometric progression formula, we need the A, we need the N, and we need the common ratio, which is the R. So let's determine the common ratio. Common ratio R is given to be second term all over first term. You remember that. Okay, so that means we will have minus 18 divided by minus 6. So we have that to be minus 18 divided by minus 6. Since we have minus at the numerator side and we also have another minus at the denominator side, we can cancel them out. Okay, next thing now will be 6 can go in 18. So 6 can go in 18. 6 in 6, that's 1 time. And 6 can go in 18 3 times. And so we have 3 divided by 1. Okay, now our common ratio equals 3. Having determined the 3 things we needed to determine the 8th term of this GP, all we need to do is to write down the formula for geometric progression. So the formula for the n term, and that's given to be Tn equals AR raised to the power n minus 1. Our n is 8, and our A is minus 6. Our R, we determine that to be 3. So let's put all those into the formula, and so we have T8 equals to minus 6 times 3 raised to the power 8 minus 1. You've gotten that? Good. So what is 8 minus 1? That will give 7. So there we have 3 raised to the power 7. And so we have T8 equals to minus 6 times 3 raised to the power 7. Okay, now, so let's try to work out this 3 raised to the power 7 using our calculator. So we have 3 exponential of raised to the power 7 equals to, that gives 2187. That's 2187. You've gotten that. So we have our T8 equals to minus 6 times 2187. So let's do the minus 6 now. To get the minus 6, you see this like a plus dash minus here. So this is the minus 6 times 2187 equals to That gave us minus 13,122. So our T8 final answer is minus 13,122.